Hello guys, welcome back to another video. So we'll be continuing with real world scenario DevOps projects. So for last lecture or last series 1 out of 3, we were able to resize an original sized image into a thumbnail sized image and then save that thumbnail sized image into S3 buckets through the use of a SAM templates and Lambda function. So for today's series, which is series 2 out of 3 of DevOps Project 1, we'll be saving the URLs and metadata of that thumbnail resized image, and then we'll be storing it in DynamoDB. So let's just get into today's lecture. So let's just do a quick recap of what we did in series 1. So the user was able to upload an image into S3 bucket, and then based on the event that was being created, which states that once an object is being put into this bucket, it invoked a Lambda function, and then that Lambda function then transformed and resized the image, which is now our thumbnail image, and then it was able to store that resized image into a new it stored that resized image as a new object into a bucket in S3. So for today's project, we now have our thumbnail resized image. So basically now we want to extract some metadata from that thumbnail resized image, which is currently in our S3 bucket. So that is what Lambda function is going to do. And then the Lambda function is also going to now push that metadata into DynamoDB. Yeah. So what are the tools we're going to use for this series, which is series 2 out of 3? We're going to use the tools from series 1. So basically the SAM, the serverless application model is still going to be there. S3 bucket is still going to be there. Lambda functions are still going to be there. We're still going to be using AWS CLI. And we are also going to introduce a new tool to this series, which is DynamoDB. So what is DynamoDB? Amazon DynamoDB is basically a fully managed NoSQL database provided by Amazon Web Service. It is designed to provide fast and predictable performance with seamless scalability. DynamoDB is basically a key to value pair form of database. So if you've worked with dictionaries in Python, whereby you have name is probably Pelumi, age, let's say 30, food, probably spaghetti. So if you've worked with dictionaries in Python, then Amazon DynamoDB should be very, very quite familiar to you, or it should be a breeze to you when you kind of get into it. So what are the components of DynamoDB? The first component of DynamoDB we'll be discussing is tables. A DynamoDB table is the primary data structure within DynamoDB. It is a collection of items, each of which is a key to value pair. Tables are schemas, meaning that each item in a table can have a different set of attributes. Another component of DynamoDB we'll touch on is items. So item is a single data record in a DynamoDB table. Each item is identified by a unique primary key, which can consist of one or two attributes, a partition key, and optional sort key. Another component of DynamoDB we'll also touch on is attributes. Attributes are the fundamental data elements within an item. Each item has one or more attributes, where each attribute is a key to value pair. Attributes can be of various data types, including strings, numbers, binary data, sets, lists, and maps. Then we also have primary key. If you're familiar with traditional databases like SQL, then you should know what a primary key is. So a primary key uniquely identifies each item in a DynamoDB table. It can be a simple primary key with only a partition key, or a composite primary key with a combination of a partition key and a sort key. So here is a pictorial representation of basically how DynamoDB works. So your table is like the complete overview of everything here. Then we have our primary key, which we said in the previous slide that consists of a partition key, or the sort key could be optional sometimes. So basically you have your partition key, which is the product ID here, and then we have items. So items are basically they're like each under the table, then we now have items. So items have like this partition key and then sort key. So you have this first item here, and then it has a partition key of 1, and then a sort key of probably book ID. you could use book ID as a source key here. Then this second item has two partition keys that are actually not unique. So this is where source key really plays a huge part, because we have an item here that is two product ID two and another one that's product ID two. So then we need the source keys to be able to like uniquely identify particular records in order to ensure scalability of our DynamoDB databases. Then partition key really helps for like distributing data across different partitions, like basically on in the database. It also like improves application performance of our database. Then the attributes are something similar to like columns, but not basically columns. So item could have like a particular attribute or even more than one attribute. So this particular item here that has the product ID one, and maybe you're sorting it based on book ID, could have an attribute of ODT and Omer. So it's kind of very fun when you try and understand and grasp the full overview of how DynamoDB works. So the table here is product. It has all these items here, and then they are broken into partition key and sort key, and then everything. This product ID and product type are basically primary keys. So everything is now under serving as either a partition key or a sort key. So the final concept I'm going to talk on DynamoDB is basically read capacity unit and write capacity unit. So what is read capacity unit? Read capacity unit is the measure of maximum number of reads per second that the DynamoDB table can perform. So one RCU represents the capacity to perform one strongly consistent read per second for items up to 4 kilobytes in size, or eventually two eventually consistent reads per second for items up to 4 kilobytes in size. So let me just give you a quick example. You have 5 RCUs. That means you can read have 5 reads per second for items up to 4 kilobytes in size. So then as your RCUs increase, then you understand what I'm trying to say. So if you have like 10 RCUs again, you can have like 10 strongly consistent reads per second for items up to 4 kilobytes in size. So if you now have that same 10 RCUs, you could have up to 20, because this is two eventually consistent reads. You could have up to 20 eventually consistent reads per second for items up to 4 kilobytes in size. So you could try and look up on what strongly consistent and eventually consistent means. I want to cover that in this video. So same thing applies to WCU. WCU is the measure of maximum number of writes per second that the DynamoDB table can perform. One WCU represents the capacity to perform one write per second for items up to 1 kilobyte in size. So let's say you have 5 WCUs. So you have 5 writes per second for items up to 1 kilobyte in size. That's just basically what it means. So let's just go into the practical part of this video. Enough of the talking and the theory. I don't want to get everyone bored up. So let's get into the practical part of the video.
So I'm going to be continuing with the code. So I'm going to work on the SAM template first before working on the app.py. So this is the Python code from series 1 that was able to resize the original image and then store it into a bucket, thumbnail size image, into an S3 bucket through the use of this lambda function here. So I'm going to first make the new modifications to our SAM templates, then I'll explain the changes that I'm making. So let's just get into it right about now. So the first thing I'm going to do is I'm going to add an environment, because we're going to make use of it in our new code. I'm going to add an environment. So I'm going to add an environment for the DynamoDB. I'm going to do first variables and then thumbnail table name. So thumbnail table name, and then I'm going to get this thumbnail table name from, I'm going to create a new resource right about now. So I'm going to get this thumbnail table name from the DynamoDB resource. So we're going to reference to the DynamoDB resource. I'm going to call it my table eventually. So let me just do it right about now, my table. So now we're going to create the DynamoDB resource. So I called it my table. So we can table. Then the type is DynamoDB. Everything is still similar like CloudFormation. If you're familiar with CloudFormation, then again, okay, all this concept will be very clear to you. So AWS DynamoDB table. So we're going to create some properties for this DynamoDB table. Okay. So we're going to create a table name. Let me just give it table name. So this is what we're going to use in the code. This is what's, and then it's going to pick, we created an environment here, thumbnail table name. So this thumbnail table name is going to make use of this table name we're going to create here in our resource. So the table name is basically going to be, I'm going to call it my table. Let me just call it my table. Then we're going to create some attributes definitions. I explained what attributes were already. So this is going to be my primary key. And then the attributes type should be string. Sorry. Sorry about this. String. Why is this string? Let me just move out of this. Then we're going to create a key schema. Okay, it's already here. We're going to make use of the same attribute name, which is my primary key. Then the key type will be hash, which is basically the same thing as partition. I explained what partition keys are during the theory parts. It allows you to distribute data across different partitions, which actually helps the performance of the whole database. So the final property we're going to describe here is the provisioned throughput. So for the provision throughputs, we're going to have read capacity units and write capacity units. I also explained that earlier. And there's also a property we could put here, but I'm not going to make use of it. It's called billing mode, whereby you can specify whether you want it on demand, or basically there's some other types of billing mode that we have, but I'm not going to make use of it. So this is all that we need for our SAM template. Alright, so we're going to continue with the Python code. So we're going to make a little bit modifications to our Python code from the previous series. Since we're going to be extracting metadata, we're going to be making use of a new module. So it's called JSON. So we're going to import JSON. Yeah, then we have to, like, since we're going to be working with DynamoDB, I'm going to create 3 new functions to make our code more reusable than what we currently have, so we don't have everything just under one function. So we're going to be creating 3 new functions. So the first one we're going to be creating is the resize function. So let me just come here and just do that. So we're going to be creating a function. We're going to call it dev resize image. Then we're going to be passing in 2 arguments. The first argument is going to be the image content that is going to be read from the image user uploads, that is going to be read. So the body part of the image, we're going to use the module bytes IO to convert it to like a binary part that can actually be read or written. So we're going to use that converted image that is now in binary format with to be resized in this as a keyword argument, basically. So this, then we're also going to take the size. So basically what we're going to do for this guy, we're going to take this one, we're going to take this part of the code here and I'm going to copy it. Then because this part was basically doing the resize part, so we're going to copy it, sorry, paste image. Then we're going to create thumbnail still similar to what is going on here. So we're going to have this guy here. Let's copy this part. But now we have our arguments, so we don't need to like specify whether we're resizing for 100. So we just change this place here to size. Since in the previous one we had to like put the exact size, but now we're passing in the arguments here already in the function. So we just need to like put the size here as an argument. So size. So the next thing is the thumbnail content. So we're going to have thumbnail underscore content, which is basically going to be equals to, so let me just copy it from here. So we can just copy it from here, paste, sorry. Then we're also going to have to save the thumbnail contents in JPEG format. So this is the new resized image. So we're basically saving it in JPG format. So I'm going to copy this one too. I'm going to take all those guys out of the main function. So the next thing also, we're going to make use of this guy. So it has to seek. So now we are done with our resize function. Then we just need to return the resized image. So that's going to be return the thumbnail contents dot read. Then now we're going to like create a new function that would upload that resized image to a new like to S3 buckets, and then create like a folder of its own which is called thumbnail, and then you can have the new objects of the new resized image in that particular folder. So let's just do that. So upload thumbnail to S3. So we're going to have three arguments for this guy: the buckets, the key, and then thumbnail. So the function here is going to be this one. We used it here already. So we're just going to copy this guy, then copy. So we're going to change this body, which is equals to thumbnail context.read. Then we're just going to change it to thumbnail, because we're passing thumbnail here as an argument already. So thumbnail. Then the final function we're going to create is the DynamoDb function, where we're saving the new created metadata to DynamoDb. So what we're going to do here is dev save metadata to DynamoDB. Sorry, DynamoDB. Then we have three keyword arguments. So I'm going to call this actual key. Then thumbnail key, and finally the buckets as the last argument. Then we're also going in this function we're going to specify the metadata in JSON formats. that we want to save to DynamoDB. So that's going to be thumbnail metadata equals to this guy. Then we want the primary key. We want the primary key. So let me just specify the arguments we need before I then specify the values. So we want the original image key also. So these are the values we're extracting from the thumbnail image that has been resized. We want the original image key. And finally, we want the thumbnail URL. So I'm just going to get into explaining the values that we will be passing for each of these guys. But before that, let me just do the last part, which is now we would have to push those, we would have to put this metadata now, push it as a new item to DynamoDB. So what we'll do is DynamoDB dot put, yes, it's not finding item, put item. Then we're going to pass in some arguments here. So the table name, which is basically equals to, we created the environment variable earlier, which is thumbnail table name. Let me just confirm the name of the table right about now. Let me just confirm the name I used. So thumbnail underscore table name, yeah. And the item is basically going to be called thumbnail underscore metadata, yeah. So we're going to go back and then we're going to specify each values for this guy. But let me come back to this. So before I do this guy, let me modify our lambda function. So basically, we're downloading the image from the S3 buckets. Then now we have a function that actually resizes the image. So let me just make some changes to this part. We're going to make use of our function inside this lambda function. So for that part, it's going to be thumbnail equals, so we have the function, we call it resize image. Then we're going to be passing our two arguments here, which is the image content and the size. So for the size, again, I'll still use 100. So image content, and then the size, I'll still use 100 pixels. I think this is not right. So let me just remove this guy. 1 second. Yeah, that's fine. So the next part, we're going to upload the image, the resized image, basically back to S3, and we've already created an upload function. So I'm going to remove all these guys too. So we're going to be making use of our function in the lambda main function. So for that, it's going to be upload to thumbnail S3. We're going to pass in those parameters, which is the buckets, the key, and then the thumbnail body. So for that, I'm just going to write buckets, sorry, and then the thumbnail key. Finally, we are going to be passing in the body, which is the thumbnail. I called it thumbnail, which is this. This is the body here, this guy here. So thumbnail. Then finally, we're going to call the last function, which is basically to save the metadata to DynamoDB. So what we're going to do here is I'm going to take this guy out because we already have it in our function. So I'm going to save the metadata to DynamoDB. Let's just call our function, and then we're going to pass in our arguments, which is basically the key, the actual key, then thumbnail key, and then the bucket. So sorry about that. We're actually passing in the key here. So it's this key we're passing into this place. The key we are getting from the S3 buckets. So it's this place here is going to be just key. So we're passing in this key here as the argument. So it's the key, the thumbnail key, and then the bucket, which is also gotten from the bucket name from the records, like the events that is being created. So after that, yeah, I've not yet created our metadata. But before we create our metadata, I could actually return something if this event is successful. So I could return something for like 200 if this actually if this lambda function completes successfully. So return, let's say status code 200, status code 200, then the body, then I'll say something like JSON.dumps. We have processed the thumbnail image successfully, and it has been saved to DynamoDb. So basically, once this completes successfully, then it's going to like if it returns 200, that means the whole code compiles and runs successfully. It's going to like show this it's going to return this to our console that we have processed the thumbnail image successfully and it has been saved or it has been uploaded to DynamoDB. That is the metadata. Let me just say, and the metadata has been saved to DynamoDB. So let's just complete this part of information that we actually need for our metadata that is being pushed to DynamoDB. So first of all, we have to specify the type, which is string. So we want the primary key, whatever we're getting from the resized thumbnail image, to be in string format. So what are we getting as the primary key? That's basically going to be the thumbnail key. So thumbnail key. So the next one is going to be the original primary key. That is the original key of the buckets. I'm sorry, of the image that was being uploaded. So for that one, we're going to put this guy like this. So S. So what is the? So it's basically the actual key. Then the final one is the thumbnail URL. So this is basically like the URL of from the folder. Then you have the object. So basically, we want to get like the full S3 URL of this guy. So we want it in string format also. I'm just gonna pass this. So since we are passing in an argument which is buckets, we would have to use the formats, the Python format method. So basically, this is going to be, I think, https / then we have the format here for what we are going to we call it basically the key you are replacing in Python. So buckets, we're replacing buckets. We've created bucket as an argument here already. So it's going to be .s3.amazon.aws.com. Then we have slash. Then we now have the thumbnail key. That's the thumbnail folder. So slash thumbnail key. So I forgot to put the comma here. I think our code is ready and good to go. So everything looks good. We're going to build this guy now. So once we build it, we should be able to deploy this code to our as a CloudFormation template, which is basically using the SAM template here. So once we deploy this guy, we're going to test it from the console to see how the whole process works from uploading an image to S3 bucket, and then we'll see how DynamoDB actually, after Lambda resizes the image and then um, processes the image and pushes it to the new buckets. Then you'll see how DynamoDB actually makes use of a Lambda function to now save the metadata to DynamoDB. So basically, let's just to push our code to the um, to the console. So let me just save this.
So now we have to build the code. So SAM build. So our build has succeeded. So now we want to deploy the current build. So basically, it's going to make use of CloudFormation. So it's going to update the current stack. So we're including a new resource, which is DynamoDB. So it's going to update the new stack and then include the new resource, which is DynamoDB. So let us just do that right about now. SAM deploy hyphen hyphen guided. Same as before. Yes, yes, yes. No, we don't want to disable rollback. Save arguments. Yes, yes. So we'll just watch everything play out in CloudFormation too. Once it gives us the confirmation, go ahead. Yes, I want to deploy this change set. So I can go to CloudFormation and see what is going on. CloudFormation. So update is in progress. You can see it's updating our stack. It's going to create a new resource, which is basically the my DynamoDB. It has done that already. So once this is done, we'll be able to like test everything and confirm that everything works as we want it to. So let me just go back to the terminal. I like to watch it from the terminal too. So it has successfully created our stack. If we go back to CloudFormation, we refresh this, we can see the creation is complete. So the next thing now, we want to test the whole process. So we first go to S3 buckets. Still going to be making use of that bucket from the previous stack or from the previous series, because we just basically updated the stack. So it's still the same bucket. So it's this one. I'm just going to delete these images. So we're going to upload new images. Permanently delete. Then I'm going to go back. I'm just going to confirm there's nothing in the thumbnail folder. I'm going to delete everything in the thumbnail folder too. Permanently delete. So I'm going to go back and back again. Let me just go back here. Sorry, this bucket. So I'm going to upload a new file and then let's see everything play out. So add files. I'm going to upload this one. Still basically the same file, but I'm going to make use of this one. Upload. So the file is basically 2.4 megabytes. We should get a resized image of a very small size.
So let's go back to our buckets. Let's see. So let's check. Yes, we have a resized image of around 3.4 kilobytes. So our S3 bucket thumbnail resizer is still working. So now let's go to DynamoDB and see if our DynamoDB can extract the metadata from this thumbnail folder that has been resized. So DynamoDB should have created a table for us. Let's go to DynamoDB. Let's go out. Tables. So we have a new table and we can see it created partition key calling it my primary key as we specified in the code with a type of string. So let's open the table. This is the table we just created with the SAM template. So currently we have 0 items. So we're basically going to explore table items from the new created table. It's going to read from the S3 bucket. So let's just run the code, or it already works. So you can see it here, items returned. So basically the my primary key is here, which is the thumbnail um, objects. I'm sorry, the thumbnail folder, and then the object in the thumbnail folder, which is the primary key. Then we have the original primary key here, and then the thumbnail URL. We can copy the URL out and let's paste it. So you can see this is the thumbnail URL that will give you access. Currently, you will not be able to access it over the internet because the buckets does not allow like public read access. So that's what we're going to look into the next series, whereby we're going to create an Amazon API gateway. Then users will be able to like access this image over the internet. So basically, it's been fun. I don't know if you learned anything new. You can drop it right down below in the comments. If you have any questions, any suggestions, anything to improve this whole lecture, you can drop it down in the comment section. So that's how to actually create a metadata, and you can create a metadata that could include the key, the URL, the primary keys, and all, and then save it into DynamoDB. It's very fun when you get into like big projects like that involves game development and all. That's when you actually be able to like appreciate this whole process in the real world scenario. That's all that I have for you today. Have a nice day. Bye.